All right, so I'm Andrew Bennett. I'm a senior software engineer at L3Harris 46. I've been doing video and graphics rendering for the past 10 years at least. And today we're going to talk about using Vulkan for video decoding, using .NET, using open source libraries, Silk.NET, and Avalonia. Initially, we were using OpenGL as the main graphics rendering, and we were limited to Windows primarily because .NET did not support Linux systems unless you use Mono or Wine. But with all the updates to .NET, now we have, since .NET 6, you got Android. Moving on to .NET 8 and .NET 9, they just released. You can now use .NET across Windows, Linux, and Android at this point. We were also looking for something that was cross-platform for graphics and video. Vulkan now supports all of these ecosystems. So it looked like the right choice. And since they just released last year, they finally finalized video extensions for encoding. It looked like the right time to actually try Vulkan out. Previously, we had different options we used for video decoding. We used a wide variety of different video SDKs, depending on what hardware we're on, what OS we're on. And they all had different requirements, some being high-level APIs, some being low-level APIs. So for video decoding, we typically used NVIDIA, Intel Media SDK, even used one API from the newer Intel stuff. And then some of the more legacy ones like Microsoft MFT, DirectShow, DXVA. I know that DirectX 12 moved on to supporting H265 as well. That one was limited to H64. But it looked like the Vulkan SDK supported everything we needed. Some things to note, some of these are very high-level APIs where you just need to pass along a video bit stream and really don't have to do anything except receive the decoded frame at the end. Other ones like VAPI, VDPAL, DXVA, you actually have to fill out all the structures based on the video codec itself. So it's a little bit more work, but you also have more low-level that you can work with for video decoding. And also another thing to note is all these different decoders spit out different video formats. You can have NV12, you can have YUV, and YUV itself is complicated in itself that it's not really a set standard. You can have, it's very fun to work with when you try getting it back into RGB or BGRA. So originally for all these video SDKs, we basically just, since we're primarily a .NET shop, we just interop the C++ and then work with the managed libraries ourselves. We're looking for an easier way to do that because the Vulkan header alone was massive and it would take a long time to actually interrupt that ourselves. Silk.NET is an open source library that actually works with a whole bunch of technologies that takes the different Khronos specs that are released and generates the C# code natively for you to work with. So it allowed us to get into Vulkan much easier. I mean, I have done the Rust and the C++ working with Vulkan as well, but since .NET Shop, just trying to stay in that ecosystem. So currently, I think the latest library for Silk.NET is at 1.3. I don't think they made the updates yet for 1.4, but it goes all the way up to video maintenance 1, I think is the last one I checked. All right, for video decoding, if you haven't started with video decoding, I'm sure most people here are familiar with it. You typically have a container that is holding your video. Common ones are transport streams, MP4, MKV, AVI. There's a few other ones. So if you want to work with video, you have to first look at the standard for this container, and then you have to extract your bit stream from this container. If you're working with audio, you're gonna have to handle it separately. There is no audio inside the Vulkan SDK. There's some open source libraries you can use on Android, but typically it's whatever is with that standard. And audio itself is complicated, so I wouldn't want to touch that, even though I have. The specs are almost as long as the video ones. I think they're actually worse. sometimes. All right. So from a high level perspective, um, really I could spend all day talking about this. I'll try to keep it as high level as I can, and then afterwards I could talk more about in the sidebars or questions later. Um, this is kind of the main workflow if you're going to actually start with video decoding. Just hit the ground running for the most part. You have your video queue and your video session. Each device and hardware you touch is going to have a different requirements. I'll get more into that later on how you handle images and decoded. You have to allocate your image views, your VK images. This will mainly be your decoded picture buffer for DPB. Depending on your hardware, Intel's typically distinct, so is AMD. I'm not sure about Android. I'd be interested to hear how they handle their images when you decode. And then NVIDIA, for most of the hardware platforms I've touched, has been coincides. You can decode and use it for a reference frame at the same time, which is really nice. So after you extract your bit stream, is the fun part. You have to go fill out all these different structures to pass into your video decoder. And then you can go ahead and start decoding. And then typically, if you have an iframe, I'll get into that a little bit later, but you get a whole frame out, and then that frame will have to be reused for decoded picture buffer to reassemble images as you move through the video. All right, so depending on the hardware, typically for most of the platforms I've seen, decode and transfer in the same family. I've just kind of separated them out depending on what workflow you're going to use. Well, most of the time you're always going to have a compute buffer because you have to get your color format back into a format that you can display in an application or something else. Typically, at the end of the day, it's RGB or BGR, depending on how you set up your graphics pipeline or images that you're using. Or if you're just decoding as a software encoder or decoder. So this is kind of the workflow as you move through. And you don't have to use all of these, but typically it just depends on what your end result is. And I'll talk about that as we talk about using it in Avalonia and which approach you want to take if you choose that as your UI front end. Decoded picture buffer. This is probably the most challenging thing to understand in video if you've never worked with video. VAPI and VDPow are good things to look at on how to handle this. But I think the best thing I found was the book by Richardson, the Advanced Video Compression Standard. That's probably the best one I've seen out there for understanding how you manage short-term and long-term reference frames and INP frames. This is a simple example here. I left out the B frames. But so after you go for your decoding process, you will have your decoded image. And then this will typically be in, it'll be like DPB or decoded image, and that will be the image layout of that format at that time. And you have to go reassign it to the reference frame so you can pass it back in as a slot to your slots. All your slots are set to -1 as you start, and then as you keep reassigning them to different places and then flushing out based on short-term and long-term references. Like I said, Intel and AMD are typically different. I don't know if the newer platforms out there actually make it coincide or not, but at least all the ones I've touched have been distinct. So that means you have your decoded output go somewhere different than your reference frames. So you have to manage where they go and transform layouts and stuff like that. All right, getting started. Typically, I work with Visual Studio 2022. You could also work with VS Code, or you could use some of the JetBrains when you're doing .NET, or you could just work command line if you really like that way. So Avalonia, just to get an Avalonia up, these are the typical packages you need. Just the core stuff to get it running. The community toolkit, MVVM. There's also a reactive one if you like the reactive style programming. You could use that one instead. But this is just the basic. If you're doing an MVVM type style application, this is probably how you set it up. Nice thing about Avalonia, though, is it runs on all of it, and you don't really have to worry about cross-compiling it between different platforms. For Silk.net, the NuGet packages you're going to use, depending on your approach, I'll get into these different approaches, but you have the main extensions, the ext, KHR extensions, the main Vulkan API, and then the core for Silk.net. And then if you're going to use windowing, then you'll need the GLFW and windowing libraries as well. All right, so looking at Avalonia, I saw there was at least 3 different ways you can use to get into it if you wanted to put Vulkan into Avalonia. There may be more in the future, but you could use a writable bitmap, which windowing or external memory, and I'll kind of go over how those ones differ. Okay, writable bitmap is probably the easiest approach because in this case, you're just decoding it, grabbing that raw frame, moving it to a buffer, and then copying it to another buffer that is a writable bitmap that's attached to the application. You still have to go through and convert it. And then you just map the memory to a buffer, and then you copy that over to the image that's attached to your UI. That's probably the easiest way to get going. Windowing, for example, this is just like how you used to use OpenGL on different applications. You'd always reattach your parent to a UI application to show that you're rendering a graphics pipeline. It's kind of the same thing if you wanted to use the windowing approach where you're rendering everything in Vulkan to a window and then you're reattaching it to an application. Using the Avalonia platform handle is basically your native platform handle that you use, and then you reparent it to, you use the GLFW window, reparent it to your Avalonia platform handle. And then here's how you do it on Windows and Linux using the native libraries there. External memory, I think this is my favorite approach that I've come across. So Avalonia now has the ability to set up Vulkan as a backend, which will allow you to use the compositor and drawing surface as external memory for a VK image that you create. So this is how you set it up for Linux and Windows and then program class. So the nice thing about this is when you create an image, you can actually say if you're going to use external memory as well. So the external memory ties into the Avalonia backend, which is hooked up to the drawing surface. So the nice thing, these 2 bits here, the first one is for Linux systems. I'm not sure which one you use if you're going to do it on Android. I'd be happy to talk to the ARM guys, see what they're doing when they do video decoding and get it into applications. And then you have your Win32 bits. So you're still going through your decode process. Then you're going to transfer it around while changing layouts. And then you're going to change your color formats, get it from YUV to your RGB format that you're using. Wait for a frame to be, an image to be available. And then you're going to transfer that into the drawing surface. A final result, using videos I found from this open source testing site, I was able to get video running inside an Avalonia application using Vulkan. I was quite happy about that. It didn't take that long, minus all the video stuff that you had to work through. But there was definitely some challenges I ran into. So if you don't have a graphics pipeline, because you don't need a graphics pipeline to render video, or if you're doing like a standalone decoder that's running on a platform where you're just writing out files, I noticed that you couldn't use Nsight or RenderDoc. They're great tools, but they kind of hold you back if you don't have a graphics pipeline. So you can't see what you're managing as reference frames. So if you make mistakes, you can't really see that you've made a mistake until you look at your corrupted video and you've done something terribly wrong because nothing's blowing up in the Vulkan API. But the nice thing is the VK configurator validation layers will tell you when you're messing something up. So that's very useful to see. But even when you don't make mistakes using the Vulkan API, you could still get a reference frame incorrect, and then you can see your pixels that you've used as reference frames. The reconstructed image is not correct. So if you got the slots wrong in the decoded picture buffer, you wouldn't actually know until you saw the end result. So I think something that'd be nice in the future to see, you could see all your reference frames and your reconstructed image, then you'd be able to tell you're messing up as you're trying to follow the standard. Also, the video capabilities are very different depending on which piece of hardware you touch. So you kind of have to manage your decoded picture buffer different per platform. But I still think it's nicer than having several video SDKs. You just have different workflows on how to manage the picture buffer for different platforms instead of creating a new implementation of video SDK each time. And that's about it. Any questions? Yeah, go for it.
So, sorry, can you just wait? I'll bring you a microphone so everybody.
So imagine, okay, my example, Vulkan's fine, but I don't know anything about video. What's your recommendation for someone who wants to understand the Vulkan video API, who knows Vulkan, but does not know anything about video?
I would honestly start by reading that Richardson book, the video compression for H264. That's probably the best way to get in it. NVIDIA does have their video examples, but if you don't really understand video, it'd be really challenging to look at it and understand what's going on. And really, I'd read that book first, just because it'd give you a better understanding. You can dive into sections as you want, but it's really hard to get started with video, especially understanding how you manage reference frames. What is a partial frame? What is a B frame? What is an I frame? It's probably one of the most challenging parts when I initially started video, to understand how do you take this compressed bit stream and how do you reconstruct images out of it. That's pretty. I mean, encoding gets even more complicated with quantization and stuff like that. But I would start there because that would give you a good understanding, because there isn't really a structure inside Vulkan. I mean, they have the slots where you manage to decode a picture buffer, but you have to understand what you're doing. Like, you have to know where you're assigning it. When you invalidate slots, you have to manage short-term references, long-term references, and those will be covered in. I'd also read the video specs for H264 and H265. They're short, little 600, 800-page documents. And they also reference other specs too, so you have to go jump into those as well. But I think that book has a really good high level on how to get you into video. But there's not really a lot of good examples out there on how to handle video. It's kind of a steep learning curve on top of Vulkan. So, yes. It would be. Oh, I went too far. Yeah, so H264 Advanced Video Compression Standard by Richardson. Yeah. Yes.
Yeah, I'm just curious what this. Thank you. What is your use case for implementing a decoder compared to using something like FFmpeg or?
So with most of the stuff I'm working with, it's broadcast video. So it's coming across a network. So I need to be able to take that compressed video and put it into an application at the end of the day. You don't really have to worry about timings and networks, but if you're writing out to a file that somebody else is going to play back in a DVR application where they're just going to watch video, it's on a local machine or something like that, you're going to have to be able to decode it and write it out to a file in a format that the computer can read, right? So FFmpeg, I mean, it's nice and it works, but typically I'm building custom solutions and I may be on a particular piece of hardware, and FFmpeg you may or may not be able to use due to license agreements. So typically you have to use an open source standard to handle video. Yes, sir.
What sort of performance difference are you getting from using this hardware as opposed to having to pull back to, or on a system where you don't have this hardware and you've got to fall back to something more CPU based? So basically, what is the emphasis, the advantage of going through this work for this for a system that does actually support it.
So
What sort of gains are you seeing?
using Vulkan versus the other ones. So I have been able to, so for example, I was able to crank through, like I had, like let's say an hour-long video, for example, and the Vulkan decoder ran so fast, I just burned through the whole video. So you have to manage your timings too. So compared to like NVIDIA and Intel, I mean, it's probably on par with NVIDIA's decoder realistically, but you can also get more granular and faster, and your resources is really what I care about, is how much resources you're using, how much of the CPU I'm using, and that overhead, and you really get a performance gain there. So I think I've seen good improvement, but if you were asking for metrics, I'd probably have to go look back and see if I could get you real metrics versus the other video decoders. But I've definitely ran it too fast where like network streams, you don't have to worry about timing, but if you're doing video files, you have to maintain a timing. So when you play back the video to the person, it's exactly the same speed and frames per second you're seeing. And you can just crank through videos using the Vulkan decoder. And then you can run it too hot where you just need to throttle everything down. Yes, sir.
Hi. So, how was your experience with using validation layers to do the Vulkan video validation? Is it as good as using validation layers for Vulkan for rendering?
So there was some stuff missing in the validation layers when you tackle video, because video was relatively new when I tackled it a year ago. They just had added some stuff, but it was still like it caught everything I was doing wrong. It was awesome to see that I got this wrong. Oh, this is why. You can go back to the Vulkan spec. Don't get me wrong, the Vulkan spec is very verbose, but it was like this section in the spec is wrong. So you go look at it and you can, oh, I made this mistake. I can fix it. And with OpenGL, you never really had that. OpenCL was pretty good. OpenCL had really good error messages, but Vulkan's even a step up from that. So the validation layers were really good. And I still had the performance I wanted. So you could still use the validation layers and still get performance, because with other ones, if you add a debug system in there, you basically break your video because you broke your timings and stuff like that. But the Vulkan validation layers still ran in parallel while I was doing video, and then I could work from there.
Thank you.
Yep.
What are you using to parse the bit streams?
The bit streams.
Yeah, for the Vulkan video.
So depending, I'm just implementing it. So I'm just following the video standard and taking the bit stream and then ripping out the SPS, the PPS, and converting it to structures from there. So I just wrote, following the standards, I just wrote the implementation to decode the bit stream. At least as much as you need for the Vulkan decoder. So you need to be able to read the different parts of that codec that you're handling and then be able to put it into the Vulkan structures from there. But I wasn't using any external libraries. I just wrote to the standard. Yes, sir.
Not really a question, but as you asked for examples, a bit of an advertisement. We wrote some examples for Vulkan video encode and decode, which are about 1,000 lines of code, so it's quite readable. So if you need something like that, we have that we are in a Vulkan engine, which is the learning engine from the University of Vienna. Yeah, so if anyone needs that, please talk with us too. We have examples for Vulkan video encode and decode, which are easily readable. Not working on every hardware, but easily readable.
That's great to hear.
Sorry, I think we've got time for just one more question, and then if you want to take it into the break afterwards. But so
Sounds
who
good.
had their? Yeah, no.
Oh, he has a microphone too.
Oh, sorry. Okay. Two questions, two short questions.
Okay, I'll make sure then.
Did you face any air spacing problems when, if you like, for example, this put a transparent UI element on top of your surface?
So Avalonia supports Z ordering, so you can Z order your elements on top of each other. So you can put layers on top of your video as you're rendering it if you needed to. So I didn't run into, I know for WPF, you definitely run into, if you're doing .NET, WPF has lots of airspace issues that are quite a pain to deal with.
Do you think it's possible the other way around, like rendering the Avalonia UI into an image and then using that image, for example, in a graphics use case to display it? Do you think that's technically possible, or how would you go about that?
About like a desktop capture implementation, is that what you're talking about? Or
Yeah, basically capturing the contents of your UI into an image and then, for example, compositing this in a Vulkan graphics path. Like
I
in
mean,
the 3D rendering, you would have like a UI and a 3D rendering.
you could do that. I'm just trying to see what the use case would be to go that way. Because you could use the external memory, attach it to a VK image and drop it into a graphics pipeline. I just don't know why you would go that way, so the other way.
For example, for VR UI rendering.
Oh, okay, I see. So you wanted, so Vulkan, since it supports off screen, you don't actually need to display it. You could just use that and push it out to VR. That would work. And you could simulate button interactions inside your VR and then send that back to your UI and back out. So you could do that. And
Right. Thanks.
that would work. Thank you.
Okay, thanks very much. Thank our speaker.